Okay, welcome back, friends. Last model of questions we need to finish. And it will take 1 hour lecture today. Okay, fine. So here is a question, beta. Just read out. Yesterday we have done the numericals which are related to the electric field boundary conditions. If you check out, all these are electric field boundary conditions. Okay, now let us start magnetic field boundary conditions here. Okay, fine, beta. Okay, beta. Interface of two regions of two magnetic materials is current free. The region 1 for which relative permeability mu r1 is equal to 2 is defined by z less than 0, and the region 2 z greater than 0 has mu r2 is equal to 1. If b1 is equal to this one, then h2 is okay. Fine, beta. Let me turn the page here. Let us draw some diagram. Here, obviously, for z less than 0, it is region 1. For z greater than 0, it is region 2. Obviously, z is equal to 0 will be the media interface. So let me draw the coordinate system here properly. Here it is x-axis. Here it is y-axis. Here it is z-axis. This is media interface. Here it is z is equal to 0. It is xy plane. Here it is surface current is equal to 0. That is what mentioned in the question. Clear, beta? Fine. Here it is z greater than 0. Here z less than 0. For z less than 0, it is region 1. With a medium parameter mu r1 is equal to 2. So the mu1 is equal to mu naught into mu r1, which is 2 into mu naught. Here it is region 2, beta. Here mu r2 is equal to 1, beta. So mu2 is equal to mu naught into mu r2, which is equal to mu naught. Okay. And what is the thing here? Here b1 is given. How much is the b1? 1.2, 0.8, 0.4. 1.2 plus 0.8 plus 4.4 z cap. Clear, beta? Is asking for what is H2, beta. What is H2? I'll find out B2. B2 divided by mu2. What is mu2 value is mu naught. So 1 by mu naught into B2 is how much? So what are the tangential components here? This is BT1. This one is BN1. Let me turn the page here. Use the appropriate boundary conditions. What are the appropriate boundary conditions, beta? We have boundary conditions like, if you remember, Bn2 is unconditionally equal to Bn1, which is equal to 0.4 beta. Is there any direct? There is one more boundary condition. Ht1 minus Ht2 is equal to Js. It is that there is surface current is 0. Here Ht2 is equal to Ht1. Now what I'll do, I'll convert this one into B. How can you do that one? Multiply and divide by mu2. Here multiply and divide by mu1. So the numerator is nothing but here it is BT2 by mu2, which is equal to BT1 by mu1. I can write this one in the vector form. What is the vector form? BT2 vector is equal to mu2 by mu1 into BT1 vector. Here it is mu2. What is mu2 beta? Mu naught. Mu naught divided by 2 mu naught into BT1. What is BT1? 1.2 x cap plus 0.8 y cap. So here it is BT2 is equal to 0.6 x cap plus 0.4 y cap beta. So what is overall B2 is BT2 plus BN2. So here it is 0.6 x cap plus 0.4 y cap plus 0.4 z cap. But what is required is the H2. H2 is equal to 1 by mu naught. H2 is equal to 1 by mu naught into 0.6 x cap plus 0.4 y cap plus 0.4 z cap. Units are ampere per meter. Okay, beta? Fine. Let us proceed further. This is a boundary condition on the magnetic field without current beta. If the questions are asked with current, with surface current, then how you need to proceed? Let us have that. Okay, let me turn the page here. Now let us consider that one. I need to do some vector adjustment here. Consider this boundary condition. What it is? Ht1 minus Ht2 is equal to Js beta. Listen carefully. Can I write this one in the vector form like this directly? Vector, vector, vector. No beta. Why? Because magnetic field direction and current direction are not same. Magnetic field direction and current direction are related by the right hand thumb rule. So there must be some cross product here. So how you can write, how you need to write this one is like this. First, let me write down. Later, I'll explain. Please be focused. Here it is. HT1 minus HT2. Cross product with N12 is equal to JS beta. This is a thing you need to remember. Why? Let me justify with the help of example. Let me consider the media interface. Here is a media interface. This is medium 1. This one is medium 2. Let us say the current, surface current is coming outside beta. If the surface current is represented with the JS beta. If the current is coming outside, how the magnetic field is tangential. If I put my thumb like this, the above it is like this, below it is like this. So how the magnetic field is? It is like this. Here it is HT2. Here it is HT1. Okay, beta. See here. What is this N12? It is a normal from medium 1 to medium 2. That is a normal from medium 1 to medium 2. That is a normal from medium 1 to medium 2 beta. Now see the cross product, is that correct? HT1 cross N12 is equal to JS. Is that correct beta? HT1 cross N12 is equal to JS. Is that correct? HT1 direction cross N12 direction is equal to JS. So the HT1 is like this. N12 is like this. Take the cross product of these two. HT1 is like this. N12 is like this. Take the cross product of these two like this. So HT1 cross JS. HT1 cross N12 is, it will come outside. So that is the direction of current. So this is a HT1 direction. HT1 cross N12. If I rotate my screw like this, it will come outside. So that is the current direction. Not only that beta, minus of HT2. That means reverse. HT2 is like this, minus of HT2 is like this. Cross N12. That means take the, so HT2 minus HT2 cross N12 is outside again. That is JS. Clear? So what it is giving beta? It is giving clear beta? Yes. So these three are orthogonal set. This is what you need to remember. Beta, see here, I have taken the normal from 1 to 2. You can take the normal from 2 to 1 also. The only thing is you need to reverse this difference. then you need to take HT2 minus HT1. Not only that, beta, observe here carefully. So what I can write is these three are orthogonal set. What does that mean? Note. HT1 minus HT2 cross N12 cross JS. These three are orthogonal set, beta. These three are orthogonal set. What does that mean? Remember, you have to take one precaution while you are using this one. If I write 1, 2 here, here also you should write 1, 2. The cross product of these two will give this one. Not only that, beta. Cross product of these two will give this one. Not only that. Cross product of these two directions will give this one. That is the meaning of this orthogonal set. Mutually perpendicular to each other. That means the first thing what you can write, you have to remember this as a note. The first thing what you can write, HT1 minus HT2 cross product with N12 is equal to JS beta. This I have already justified. The second one is cross product of these two will give this one beta. Means N12 cross JS is equal to HT1 minus HT2. That is also true. Means N12 cross JS. N12 is like this. JS is outside. N12 cross JS is HT1, this side. N12 cross JS. JS is outside. N12 is like this. N12 cross JS is, if I rotate my screw, it will go in the HT1 direction. Not only that, the third combination is also possible. What is the third combination, beta? Cross product of these two will give this one. But there is one observation you have to make here. Mutually perpendicular. Yes, very good. The cross product, when you are taking the cross product of these two, this is a unit vector. But this is a magnitude, this is a magnitude and direction. Here it is magnitude, here magnitude and direction, magnitude and direction, magnitude and direction, magnitude and direction. Okay. But when you take this one beta, here magnitude and direction, but this is a unit vector. There is no magnitude. That means I cannot write like this. Mathematically, it's not correct. What I mean to say here is I cannot write like this. JS cross HT1 minus HT2 is equal to N12. Why? Because its magnitude is equal to 1 beta, but it will have some magnitude. So 5 will not be equal to 1. So left side also I should take the unit vector. That would be the appropriate one. What I mean to say is this one. So here it is JS. JS unit vector is equal to HT1 minus HT2. You have to take the unit vector of these two. Resultant is equal to N12. So JS cross HT1, JS cross HT1 is equal to N12. Js cross HT1 beta. Js is outside. Cross HT1. HT1 is like this. Js is outside. So the Js cross HT1. Js is like this outside. HT1 is like this. So Js cross HT1. If you take the cross product of these two, I'm going to get N12. Okay, I leave this one. You do not find that much applications of this one. No numericals on that one, but you should know how to write the things. Okay, fine. So ultimately, what you need to remember when the surface currents are given is this one better. You have to remember this one. Just to recall this note and make a use of that. That makes our life simple. Let us have some questions to appreciate this one. Okay, I'm going to turn the page. A plane Z is equal to 0 separates two media where medium 1 in brackets Z less than 0 and mu1 is equal to 3 mu naught bracket close and medium 2 Z greater than 0 with medium parameters mu2 is equal to 6 mu naught. If magnetic field in medium 1 at interface is H1 is equal to 3x cap plus 6y cap plus 9z cap ampere per meter. Find magnetic field in medium 2 at the interface. Assume surface current to be Js is equal to 3x cap plus 4y cap. Units are ampere per meter. I'll draw some rough diagram here. Plane Z is equal to 0 separates the two media beta. Here it is medium 1 is defined with the medium parameters like this. Medium 2 is defined with these medium parameters. So in the medium 1, the magnetic field intensity at the interface is this one. Magnetic field intensity in the medium 2 is asking and the surface current is given. Yes, let me draw the coordinate system here. Here it is x-axis, here it is y-axis, here it is z-axis. Okay, beta. Here it is medium 1. And with the medium parameters, mu1 is equal to 3 mu naught. This is for z less than 0. This is for z greater than 0. And here it is surface. Here it is z is equal to 0. And here it is surface current. How much is that? Js is equal to 3x cap plus 4y cap beta. And here it is second medium. Mu2 is equal to how much? 6 mu naught beta. Okay. And what is the H1 here? H1 is equal to 3x cap plus 6y cap plus 9z cap. Ampere per meter. Beta, surface current is given. What is the normal acting from 1 to 2? Normal from 1 to 2. This is normal from 1 to 2. Is z cap beta. Clear? So what are the tangential components here? X and Y are tangential components. So here it is HT1. This is a normal component, HN1. So I'll going to turn the page here. So how do you find out the normal components beta? Directly you can use this boundary condition. Bn2 vector is equal to Bn1 vector, which is mu2 into Hn2 is equal to mu1 into Hn1. Hn2 is equal to mu1 by mu2 into Hn1. What is this mu1 beta? 3 mu naught. 3 mu naught by 6 mu naught into Hn1. What is Hn1? Is 9z cap. So here it is. Hn2 is equal to 3z cap. Then how do you find out the tangential component beta? There is a note I have given when the surface currents are given. This note you have to use. What it is? HT1 minus HT2. Cross N12 cross JS. You have to take one precaution while you are using this one. If you take here 1, 2, here also 1, 2. These three are orthogonal set. Okay, beta, fine. Let us proceed further here. So what is required is this one. So I need to take the cross product of these two. Fine. That's all it is. So what is required is HT1 minus HT2 is equal to N12 cross JS. From here, HT2 is equal to HT1 minus N12 cross JS. HT2 is equal to HT1. What is HT1 beta? Is this one. 3x cap plus 6y cap. 3x cap plus 6y cap. Minus N12 cap. What is the normal beta? From medium 1 to medium 2 is a Z cap. Here it is Z cap. Cross surface current. How much is the surface current? 3x cap plus 4y cap. Here it is the x-axis. Here it is the y-axis. Here it is the z-axis. So here HT2 is equal to 3x cap plus 6y cap. What is Z cross X is? Z cross X is 3y cap beta. Z cross Y is minus 4x cap. So here it is HT2 is equal to 7x cap plus 3y cap. So here it is HT2. Here it is HN2. So what is overall H2 vector is 7x cap plus 3y cap. First you can write it like this. HT2 plus HN2. Here it is 7x cap plus 3y cap plus 3z cap. Units are ampere per meter. Let us have one more question beta. If you just follow that note, that's enough. You can tackle with the questions. Yes. Fine. Let us have one more question here. Okay, beta. I'll write down the question here. I'm going to turn the page. This was asked in EC paper for 2 marks. A current sheet J is equal to Ny cap ampere per meter lies on the dielectric interface X is equal to 0 between two dielectric media with epsilon R1 is equal to 5, comma, mu R1 is equal to 1 in region 1 in brackets X less than 0 and epsilon R2 is equal to 2, comma, mu R2 is equal to 2 in region 2 bracket X greater than 0. If the magnetic field in region 1 at X is equal to 0 minus is, that means just below the interface is H1 is equal to 3x cap plus 30y cap ampere per meter. The magnetic field in region 2 at X is equal to 0 plus is. Diagram is provided in the question beta. This is a diagram provided. Coordinate system is also provided in the question itself. Here it is x-axis, here it is y-axis. Here it is region 1. Here it is region 2. Okay, this is x less than 0. Here x greater than 0. And medium parameters also provided. Yes, everything is provided. Beta, see here, this is a media interface. X is equal to 0. What is the normal from medium 1 to x is equal to 0 means YZ plane it is. Y and Z are tangential components. And what is the normal here? Here it is x cap. And what is the mu1 here? Mu1 is equal to mu r1. Mu r1 is equal to 1 beta. So here it is 1 into mu. It is mu r1 is equal to 1. What is mu2 beta? Is mu r2, that is 2 into mu naught. Clear? Yes. Okay. And what is the magnetic field in the medium 1 is given H1 is equal to here H1 is equal to, can you able to hear me? Here H1 is equal to how much beta? 3x cap plus 30y cap. So here, whichever is constant, that itself is a normal. Here it is Hn1. It is a tangential component, Ht1. Clear? I'll going to turn the page here. So what is the boundary condition, beta? Here is a boundary condition we have. Bn2 is equal to Bn1 vector. So Hn2 vector is equal to mu1 by mu2 into Hn1 vector. What is mu1 beta? Mu naught by 2 mu naught. Mu naught by 2 mu naught into Hn1. What is Hn1 is 3x cap. Three by 2 x cap. That is how you can directly find. But what about the tangential component? You need to recall that note what I have provided. What is that note beta? Write down one more time. What is wrong in that? Ht1 minus Ht2. Cross N12. Cross Js. These three are orthogonal set beta. What is required is this one. And I am repeating again and again. What is the precaution here? 1 to 1 to. So here Ht1 minus Ht2 is equal to N12 cross Js. HT2 is equal to HT1 minus N12 cross JS beta. So just substitute these values here. HT2 is equal to HT1. What is the HT1? HT1 is 30 Y cap. Minus N12. What is N12? Normal is a X cap. Cross JS. What is the JS beta? Is 10 Y cap. It is mentioned in the question. So X cross Y is Z beta. So here it is. HT2 is equal to 30 Y cap minus 10 Z cap. So here it is HN2. Here it is HT2. So what is the H2 vector beta then? H2 vector is HT2 plus HN2 beta. So here it is 1.5 X cap plus 30 Y cap minus 10 Z cap. Units are ampere per meter. $4.5. How? 1.5. Which one 4.5? This is 4.5 beta. Okay, thank you. Small correction here, it is 4.5. Previous question. Let us have one more model of question. I'm going to turn the page. Is it clear? Yes. The Z is equal to 0 plane contains a current sheet for Z less than 0. Mu R1 is equal to 5 and epsilon R1 is equal to 2, and for Z greater than 0, mu R2 is equal to 20 and epsilon R2 is equal to 1. If the magnetic fields in the magnetic field in the two regions are H1 is equal to 6x cap plus 5y cap plates 8z cap ampere per meter, comma H2 is equal to 2x cap minus 3y cap plus 2z cap ampere per meter. Find the current density in the current sheet. Find the current density in current sheet. Let me draw the diagram here. Some rough diagram I'll draw. So on the Z is equal to 0 plane, there is a current sheet. That means current is flowing on the interface. You can write like this. For Z less than 0, the medium is provided. For Z greater than 0 also, medium is provided. Here it is a medium 1. Here it is a medium 2. The fields are provided in the medium, these mediums. H1 is equal to 6x cap plus 5i cap plus 8z cap. Ampere per meter. What is the H2 beta? H2 is equal to 2x cap minus 3y cap plus 2z cap ampere per meter. He is asking what is the surface current beta. Now fields are given, he is asking surface current, reverse, something reverse. Remember what is the normal to the interface? He is asking what is the surface current here, Js. What is the normal to the interface from the medium 1 to medium 2? N12 cap is equal to positive Z cap beta. What is the tangential components here? X is equal to 0 plane. X and Y are tangential components. This is HT1. This one is HT2. Bus khatam. Use that note what I have provided. I will going to turn the page. What is the note beta? HT1 minus HT2 vector is equal to N12 cross JS beta. What is required is a surface current. This one is required. So I need to take the cross product of these two. That means JS is equal to HT1 minus HT2. This model was not asked in even in the. This model was not asked so far. This question was not there. This type of question was not there in EC paper also, in any competitive exam. Let us discuss all the models. Question can be anything. That is the story. So here it is JS is equal to. What is HT1? 6x cap plus 5y cap minus HT2 beta. What is HT2? 2x cap minus 3y cap. Cross product with Z cap. Here it is 4x cap plus 8y cap. Here it is x cap, y cap, z cap. So what is this JS beta? X cross z is minus. It is minus 4y cap. Y cross z is x. So here it is plus 8x cap. So the JS is equal to, put it in order, 8x cap minus 4y cap. Units are ampere per meter. Let us have last question beta. I'll going to turn the page. Last topic, last question. This was also asked in EC paper. So I'm solving EC questions so that I left that electrical question to you. Of course, in your base material also, they have provided the solutions. If you do not get the solutions, you can cross check. Okay, fine. Let us consider the last question. Last question. The region shown below contains a perfect conducting half space and air. The surface current on the surface of the perfect conductor is Ks is equal to 2x cap ampere per meter. The tangential H field in the air just above the perfect conductor is. Here is a diagram provided in the question itself, beta. Here it is the X. This is how the current flow happens. And here it is a perfect conductor. Here it is the y-axis. Here the surface current he has represented with the Ks beta. Doesn't matter. Here it is a Ks. Here it is the air. Here it is a perfect conductor. Options are provided. Option A is equal to x cap plus z cap by into 2 ampere per meter. Option B 2x cap ampere per meter. Option C minus 2 z cap ampere per meter. Option D 2 z cap ampere per meter. Beta, here it is y-axis. You can directly, without using anything, just you can decide the answer by the direction. If you put your thumb in the direction of current flow, your fingers will show the direction of magnetic field. If I put it like this, my fingers are coming outside. Outside means which direction? Z direction. So what is the answer? Option D is the answer. Okay, beta. One of your friends are saying electrical questions are easy. Okay, whatever it may be. What is the answer? It is a boundary condition. It is a air to conductor. Let me give some naming beta to this one. Here it is the medium 1. Here it is the medium 2. What is the normal from medium 1 to the medium 2? N12 is equal to y cap beta. Is asking what is the magnetic field, tangential magnetic field just above the conductor. Inside the perfect conductor, all fields are 0, isn't it? Let me turn the page here. What is the note I have given? HT1 minus HT2 cross N12 cross JS. You need a tangential component in the air just above the conductor. Tangential component is required. That means this is required. So I should take here HT1 minus HT2 is equal to N12 cross JS beta. What is required here? Field in that medium 2, isn't it? So, and one more thing here. Field in the medium 1 will be 0 because it is a perfect conductor. All fields are 0 inside the perfect conductor. So here it is 0. So minus HT2 is equal to N12 cross JS beta. So HT2 is equal to JS cross N12. What is JS beta? It is, yes, it represented is the KS. Doesn't matter. So here it is 2x cap cross normal. What is the normal from medium 1 to the medium 2? Y cap. So HT2 is equal to 2z cap is ampere per meter. Okay, beta. So these are the varieties of questions on the boundary conditions. We have discussed all the models. So this essentially completes the course which is required for this essentially completes the course which is required for your GATE exam as well as for your engineering services and other competitive exams. Okay. So we have discussed each and every topic to the greater extent. We have discussed all the topics, all the models. Okay. And what must be our preparation strategy? You have to make some short notes here. First, you need to study my notes and you need to make a short notes of all the formulas. And then you need to solve volume number 2 questions. And then you need to solve GATE ES engineering service exam. Rama. ECA electrical papers. Still, if you have doubt, still if you have time, you can go for this book. 2008 plus solved questions by Syed Nazar. So you can send your doubts to my number. You can just WhatsApp me. Please don't make a call. Just take a pic of your question and you can send it to me. I'll answer them with the text, or if required, I'll going to post the solution or explanation or a voice chart according to my convenience. So as I said earlier, for the GATE exam, minimum 2 to maximum 4 marks are expected, to be very frank. But you cannot see this subject as an isolated subject. See here, if you are really preparing seriously, preparing for a competitive exam, each and every mark is important. Each and every mark is important. And it is not isolated subject, isn't it? You are learning the same things. You are learning the same things like a yes, bits and bytes. Skin effect and pointing theorem is not there in your syllabus. My name is Vivek. Vivek, V-I-V-E-K, Vivek Nanda. Not Vivek Oberoi, Vivek Nanda. Vivek Narsampalli. Don't you know my name? Okay. Vivek Narsampalli. Okay. It is not the end of your okay, fine. Okay, beta, anything if you want to ask, you are always welcome. This would be the end of your subject. This essentially completes the course which is required for your GATE exam, engineering services, and other PSUs. I'll wish you very success in your life, even for the exams what you're going to write. All the best. May God bless you all. Thank you, beta. Yes. Thank you. Thank you. Thank you. You have to concentrate on all topics. Thank you. Bye, friends. See, Shreyas, Sasi, do how much you can do. Spend some proportionate time. Because the weightage is 2 to 4 marks, I'll expect you to spend the same amount of proportionate time on my subject. Okay, shall I close the session then? Bye bye. Take care. God bless you. Bye, friends. Bye, bye, bye. Okay. Sasi. Thank you. Happy Diwali. Okay, friends. Then bye bye. Take care.